In this exercise we're going to find the inverse of some 2 by 2 matrices. Now remember, if you have a matrix A, B, C, D, then if you want to find the inverse of this, the first thing that you need to do is find the determinant. So you need to find the determinant of A, B, C, D, which is just the difference in the products of the diagonals, so AD minus BC. Then in order to find the inverse, what we do is we divide the whole thing by the determinant, and we switch the A and the D around, and we multiply the B and the C by minus 1. So our inverse is going to be equal to 1 over AD minus BC, the determinant of the matrix, times by swapping the A and the D over, the D and the A swap places, and the B and the C are multiplied by minus 1. So for our first matrix, 2, 3, 1, 2, the determinant of 2, 3, 1, 2 is equal to 4 minus 3, which is just equal to 1. So the inverse of 2, 3, 1, 2 is just equal to 1 over 1 times by swapping the 2's over, well that makes no difference in this case, and then multiplying the other diagonals by minus 1, which is equal to 2 minus 3 minus 1, 2. If we wanted to check that, we could multiply our original matrix by what we think is our inverse, 2 minus 3 minus 1, 2. If we've done this correctly, we should get the identity matrix, which remember is a matrix with 1's on the diagonals and 0's elsewhere. So this is going to be equal to, the top left, 2 times by 2 plus 3 times by minus 1, which is just equal to 4 minus 3 is 1. Then to get the top right, take the right hand column, multiply it by the top row, so minus 3 times by 2 plus 2 times by 3, so that's minus 6 plus 6, which is just 0. Then bottom left, we get 2 minus 1 multiplied by 1, 2, so 2 times by 1 minus 2 times by 1, which is just 0. And then finally, minus 3 times by 1 plus 2 times by 2, so that's minus 3 plus 4 is equal to 1. So straight away we can see that we've got our inverse correct. We can do the same with our second inverse. The determinant is equal to 1 times 1 minus 2 times by 2, so it's the difference between the product of the diagonals, which is equal to 1 minus 4, which is equal to minus 3. So our inverse is equal to 1 over minus 3, and then we swap the 1 and the 1 over. Again, that makes no difference. Then we multiply the other two elements by minus 1, so minus 2 and minus 2, which gives us an inverse equal to, dividing all of the elements now by that determinant, minus 1 over 3, 2 over 3, 2 over 3, and minus 1 over 3. We can check this again by multiplying our original matrix by what we think is our inverse, and we should get the identity matrix out. So top left we have 1, 2 times by minus a third 2/3, so that's going to be equal to minus 1/3 plus 4/3, which is just 1. Then, to get the top right, 2/3 minus 2/3 is 0. Bottom left, minus 2/3 plus 2/3 is 0. Bottom right, 4/3 minus 1/3 is just 1. So again, we've got our inverse correct. The final case, we haven't got any numbers in here. We've just got a, b, and 2a and 2b. So the first stage, remember, find the determinant. So the determinant of a, b, 2a, 2b is just going to be equal to 2ab minus 2ab, which is equal to 0. Now we can't divide through by 0, so in this case the inverse doesn't exist. But the reason that the inverse doesn't exist is because the two rows are not linearly independent. The bottom row can be written as just a multiple of the second row. In matrices we talk about the rank of the matrix. If this matrix had two linearly independent rows, it would have a rank of 2. However, this matrix only has one linearly independent row, and the other row is just a multiple of row 1. Whenever that happens, an inverse doesn't exist.